Hey class, here is an explanation and an intro to hyperbolas. So I'm going to call your attention right off the bat to in your book. They have this huge long piece, and it has all of these pieces to it. And what I'd rather do is just show you a couple and show you how you do them, and from there we can come back to this, and at the end we'll investigate what all of those are and how what we had uh, seen already will give us the exact same information. The only thing we need, just like with the ellipse, is that in there c squared was a squared minus b squared, and this time it really is the Pythagorean theorem. So let me show you a couple examples. First of all, let's take something like x, and I'm just making these up, x squared over 4 minus y squared over 25 equals 1. So here's how you're going to do this. Because this is the same as x minus 0 squared, and this is the same as y minus 0 squared, that means it's centered at the origin. So it is centered still at the origin, so I'm just going to mark that. And just like we did before, we look at what's under the x, and I take the square root of that. And the square root of that's 2. So what I'm going to do is go right 2 and left 2. And then we look under the y, and we take the square root of that number, and we get 5. So I'm going to go 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And now, here's where, if this was a plus, we would draw this in. It would be an ellipse, and we would be done. And so, just to say it again, this graph would be there if all that changed in that was a plus sign. But since it's a minus in between, it's not an ellipse, and it turns out to be a hyperbola. Okay, so here's where the difference comes in. So we saw, look under the x, go left and right that amount. Look under the y, go up and down that amount. Figure out your center and mark that first. But now here's where we alter what we do. So what we're going to do is make this dotted box. And the nice thing is those 4 points are midpoints of each side of that rectangle. Now, this rectangle has nothing to do with the hyperbola. It's just going to help guide us to where it actually lives. And so what we're going to do, in addition, is through the top corner of the box, the center, and the bottom corner in a diagonal, we're going to make a dotted line. And so I'm going to go up through the box there, down through the box there, down this side through the box, and up that side through the box. All right. Now, before I had a way of saying if this was a plus and we were in the ellipse case, since it was a bigger number under the y, it would be stretched more in the y direction. What I say is this, and so I'm going to stop here for a second. I'm going to show you something that is extremely useful. So let's come over here, and let's say I have this. Let's say I have x squared over a squared minus y squared over b squared equals 1. We would do our thing, and we would say, okay, well, we have the square root of a squared is a, so somewhere here is negative a, and somewhere here is a. And then we have the square root of b squared is b, so we're going to have a b up there and a b down. And I don't know what value they are, so I'm just kind of marking it in there. Now, if I wanted to figure out the x-intercept, that is when y equals 0. And if y is 0, 0 squared is 0, and 0 divided by any non-zero number is always 0, and anything minus 0 stays itself, and so we would get x squared over a squared equals 1. Multiplying both sides by a squared, I see that the a squareds would cancel, so I'm going to do that here. and we get x squared equals a squared. Square rooting both sides, I get x is plus or minus a, which means that y was 0, so I've got a comma 0 and negative a comma 0. Now let's do the same thing for the y-intercept. So if I want the y-intercept, that's when x is 0. Now if x is 0 for the same thing, this is going to disappear. But notice what I have now. I've got a negative fraction. That's going to play an important role in just a second. So I've got negative y squared over b squared equals 1. Now I need to multiply both sides by negative b squared. Those will cancel, and I'll get y squared is negative b squared. B squared is always positive. If you square any number, it's positive, because even a negative times a negative is positive, or 0. So the proper way of saying it is non-negative. But, so b squared is non-negative, so it's going to be 0 or a positive number, which means this truly is a negative number on this side. So when I square root both sides, I am square rooting a negative number, and that, my friends, is imaginary. So what that tells us is there are no y-intercepts. Now, if we did this, and I'm just going to highlight something here just for a second, and because I don't want to rewrite the whole thing, so watch this. What I'm going to do is, let's say this switched to y first, then x. Then what would happen is when we wanted the x-intercept, so I'm actually going to darken this in over. So let's say that's a y now, and that's an x. Now, since the negative is attached to the x, when I let y be 0, I'm going to have an imaginary intercept on that x-axis. And so, but when I let x be 0, finding the y-intercept, then y squared will be a squared, and everything will work out fine. And so what I say then is this, and this is important. There are two ways that a parabola will open. It'll either open like up and down, or it will open left and right. And there's a way that you can tell, and here's how. So in this, notice there is no x-intercept whatsoever. Since there is no x-intercept, see, this one had no y-intercept. So if I come back here and do this and that. Here's how it originally was. This one had no y-intercept, and so here, notice there is no y-intercept, so this graph is going to look like that. The other one, when I changed it to y squared over a squared minus x squared over b squared equals 1, in that case, we wouldn't have an x-intercept, and so that one goes with this graph right here. So that goes with that graph, and that goes with that graph right there. Watch over here. In this case, using the reasoning above, we can see, and they tell us, this is not, all right, so they're trying to explain it, but they don't give how do you tell which one is which in here. You need to know, is it a vertical or a horizontal parabola? And so here's what I think. Notice how the negative is attached to the y. So that negative is attached to the y. And that gives us a bottleneck. So I call this kind of a bottleneck. You know, like you have a bottle, and the neck, it shrinks down like that. So the negative is on the y, so that means the bottleneck goes in the y direction. If the negative was attached to the x, the bottleneck runs in the x direction. So you can run through here by if that was a liquid. And so that's how we can tell which way is which. Now that we've established that, let's go back to this problem. Using that exact reasoning that we just saw, I take this and I say, okay, the negative is attached to the y in this case. If the negative is attached to the y, the bottleneck opens in the y direction. So I can flow through in the y direction, the up-down direction. What that tells me is this. Since it's going to go like this and this, these points here and here, they don't mean anything. So those points do not mean anything there. What is true then is this. This point becomes an actual point on the graph, and it comes from the fact that we know it's going to look like that. And this isn't a point on the graph. And in a hyperbola, this is where the box and those diagonal lines help us. It's going to come out like that, come out like that, come like that, and like that. And so that's going to be what it looks like. Now, I'm going to open Desmos and show you by graphing this, and we'll look at all of the pieces we have, then we'll go back and look at the book. So, if I open Desmos, and we had this, we had x squared divided by 4 minus y squared divided by 25 equals 1. So there is the graph that we get. And I want to call your attention to these 2 points. Those 2 points are on the graph, negative 2, 0, and 2, 0. If you look at our graph right here, and look, those almost line right on top of each other. If I switch back and forth, they look pretty close, even in my crappy drawing. But we said that this would cross at negative 2 and 2. And so negative 2, 0 is one vertex, and 2, 0 is the other vertex. And so that's how you get that. Now, they have this big deal in the book, too, about the equation for the asymptotes. You see right there. It has the equation of the asymptote is that. I don't like that. That seems like a huge formula, and I'm not kidding you. The only thing I need is this right here. And that is exactly the way the Pythagorean theorem is written. To do any work with a hyperbola, that is the only thing that you need to know. So, let's look at a different example, and so I'm gonna make it a little bit harder, and we'll see, and then we'll go to the book. So, let's say in this one we have let's say x minus 3 squared over 9, or no, we did an x one already. So let's make it y minus 3 squared over 9 minus x plus 2 squared over 49 equals 0. And let's not make it, well, no, we'll leave it there. Okay, so here's a few important things right off the bat. The center is exactly the same as the way we got a center of an ellipse. You take the opposite in each spot. And so, for my center, I see that the opposite of that for the x is negative 2, so it's going to be negative 2. And the opposite of this is positive 3, and that's with the y, so that's going to be positive 3. So now I know where this thing is centered. So it's centered at negative 2, 1, 2, 3. Right there. Okay, so now I'm going to look under the y, and the square root of that number is 3. So I'm going to go 1, 2, 3 up, and 3 down puts me on the x-axis. That's kind of cool. And then we look what's under the x. That's 49. Square root of that's 7. So now from the center, notice from the center I went up 3 and I went down 3. That's because the square root of 9 is 3. And that is with the y, and the y does the up-down stuff if we labeled the axes. So then when we come to the x, we look at that piece, and that square rooted is 7. So again, I'm going to go from here, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So there's 1, 2, 3, 4, 5, 6, 7, right up there, and 1, 2, 3, 4, 5, 6, 7, right there. Now, those points don't really do anything for me. They serve to make a rectangle. That rectangle I don't really care about either, because what I want is these lines that go through the edge, the corners and the center of that rectangle. Now I make a choice and I say, who gets the negative? The x gets the negative. And so, since the x gets the negative, the bottle cap runs like that. Since it runs like this, or the bottleneck, sorry, you know what I mean. Since the bottleneck runs that way, I know that that point and that point are going to be legit points. And so I tend to like darken them in a little bit more to say that those are really there. And then just as before, we're going to follow this up and over and follow this out and down. And there is that graph. So it's y minus 3 over 9. So here, let's do this. We have y, minus 3 squared over 9 minus x plus 2 squared, x plus 2 squared divided by 49 equals 1. And this time I'm going to put in a few of the things that we thought we knew. So I thought that it would be centered at negative 2, comma 3. And if you look there, that looks pretty good. And then we said we were going to go up 3 and down 3 from that. Well, if we went up 3, then y would be 6. And if we went down 3, y would be 0. Then we went left and right 7. Now what I'm going to do is, and I can't use my laser pointer on this, so look at this point right here. I'm turning it on and off in 2. So I was at an x value of negative 2. Well, negative 2 plus 7 is 5. So I'm going to say x equals 5. And then if I take negative 2 minus 7, I'm going to say x is negative 9. And I'm going to turn the center back on. And then I'm going to come over here and show you something really cool. So I told you before, they make a big deal about the equation of the asymptotes. And they have this big, long, convoluted thing. If you want to memorize it, it's absolutely fine. And there's no harm or foul in that. But I'm going to show you right now an easier way that you can use your own intelligence and not need to memorize an extra formula for no apparent reason. Here's how we're going to go about that. I know a point on both of these lines. That point is the center, negative 2, 3. So what I'm going to do is this, and I know the slope, because on this line, what did I do? I dropped 3 and ran 7, right? So my slope should be negative 3/7. So I'm going to say this, using y minus y1 equals m x minus x1, I'm going to say, okay, then y minus 3 should equal, what was that slope again? It was negative 3 and then 7. Okay, so negative 3/7, and then x minus negative 2 makes it plus 2. And then if I add the 3 over, I would get negative 3/7 x plus 2 plus 3. I'm going to graph that now. So I've got y equals negative 3 divided by, negative 3 divided by 7, parentheses, x plus 2, parentheses, plus 3. Plus 3. If you look now, that goes through that point on that corner. It goes through that center of the box right there. And it goes through that corner of that box right there. If I then came back to this and said, okay, what if I'm on the other line, this line? Well, in this case, I rose 3 and ran 7. And so that would give me a positive 3/7 slope. And I would have the same point here. So it's y minus 3 and x plus 2. But in this case, I have a positive 3/7. And so watch what happens when I do that. So now I've got 3 divided by 7, parentheses, x plus 2, get out of there, plus 3. And that hits the lower left corner, the upper right corner, and it goes through that spot right in the center. And so those are those lines right there. Now notice, if you look at those values, and I'm even going to do this, so I'm going to take this, I'm going to come here and use that, save it, then we'll come here, I'll take this, clear the page, if I insert both of those, and we had, the equation was y minus 3 squared over 9 minus x plus 2 squared over 49 equals 1. In that case, it looks exactly like this right here, and that we see that A is 3, so A should be 3, and B should be 7. So here I've got A is 3, B is 7, and I've got the HK, that's my center right there. It's on that page right there. That center for me, I knew. That center was -2, +3. So now I want to call your attention to this right here. So they tell you, using that reasoning, there is the equation of the asymptote. So it's supposed to be y equals plus or minus a over b. Well, a is 3 over b is 7. And then x minus h. Well, h is -2, so x minus -2 is x plus 2. And then it's plus k, and k is 3, so it should be plus 3. And if you look at that, there it is with the minus, and there it is with the plus right there. That is exactly what I typed in, but I didn't need the formula. All I needed to do was just write it and move that over. And so I use kind of this point and what I did to get to another corner of the box to figure out my slopes. And then I have a point, and once you have a point and a slope, you have a point slope formula. And so it's real easy to get the equation of those asymptotes, as they're called. And again, just to go back here, you can see that they do hit everywhere I have claimed and they go through the center and the corners of that rectangle. So then let's come back here and I'm going to show you something. So here's what they have. They have two different pictures. So, and what they're trying to do is, this one it does matter. So in the other one, I'm going to tell you, the a squared is always the bigger number. And in this one, the a squared is always what's under the x value, or what's under the positive term, sorry. So in this case, x doesn't have a negative out front, and so then it gets the a underneath. And over here, y doesn't have a negative out front, and so it gets the a. What that says then is, then it says the transverse axis is parallel to the x-axis. So notice, in this case, the y gets the negative, and so it opens in the y, and the transverse axis, if we went back here, the transverse axis is a line segment through the center of the parabola and the vertices as endpoints. And so it's the one that the actual vertices is going to be on. And so in this case, over here, the y gets the negative, which means it's going to open in that fashion with the bottleneck in the y direction. And that means that would be a vertex and that would be a vertex. So that transverse axis is parallel to the x-axis. In the other one, the x gets the negative, so the bottleneck's going to open in the x direction. That means this is a vertex and this is a vertex, and that has a vertical transverse axis, or parallel to the y-axis. So they're using, it's better vocabulary than mine, but I'm telling you, whoever gets the minus, that tells you which way it opens. And so since x gets the minus, it opens that way. So this graph is that, whereas the graph of this is this one down here. So then they say this, the length of the transverse axis is 2a. Well, in my picture, if I went up 3 and down 3, a was 3, and so 2 times 3 is 6, but if that's 3 and that's 3, then that's 6. And so I can tell then that this is the transverse axis. And I know the length of it is 6. And I can get that just from my picture. And I don't need to memorize a bunch of other pieces for that. What happened to... Okay, so then back to this. It says then the coordinates of the vertices are, and is this the one that we have? Let me just make sure. Yeah, the x gets the negative, so we're in this case. So then it's h and then k plus and minus a. So let's see what that means. So in this case, we have h. H is 3, or h is -2, sorry. So it's -2. And then it should be, let's go back to the book. It says k plus or minus a. So k plus or minus a. So let's see. So k plus a, remember a was 3, so k, and k is 3. So 3 plus 3 should be 6. And then we have -2, and then it's h minus k. K minus a, sorry. And in that case, k is 3, minus a is 3, and 3 minus 3 is 0. So we should get -2,6 and -2,0 as our vertices. And right there, and right there, those are the actual vertices in there. And so you can see them right there, and I didn't need that in there. The length of the conjugate axis, so the other axis, basically the width of the rectangle, if the length is the transverse axis, it's going to be twice b. But you went over b and over b, so it's going to be double b. The coordinates for the co-vertices, just trust me on this, if you plugged in the h, plus and minus b, and the k, all that is, you guys, is these, the left and right, it's these values right here, these two, but I know what they are. We went -2 plus 7, which was 5, 3, and then we went -2 minus 7, which was -9, 3, and those would be those two values, and that's exactly what it says in there. Now the distance between the foci, so here's something that I haven't talked about yet, is foci, and foci look like this. So if you have a sideways opening parabola, these are vertices. You'd have a box somewhere in there, and you'd have your asymptotes there. The vertices, or the foci, sit outside of kind of this box, whereas for an ellipse, the foci are inside. So I would call this inside the ellipse, and I would say this is kind of in both of the dish parts, but it's on the outside. And that's where you only need that one formula for that. And so if you know what C is, then the foci have to live inside of it. And what I think of, you guys, is this is a satellite dish, and this is the eye of the dish. And so the eye, and that's really what it is, the focus. If you took calculus 3, you would learn that the focus is where any point reflected in, if you come in at a right angle, straight in, all lines get directed right to that point. That's why you get a good signal with a satellite, and that's why you need that eye on the outside. So you have the dish, and then you have the thing that comes up, and you have the eye right there. That eye is taking all of those rays, and it's bouncing them into that eye so it can process the information. But it is a focus of a parabolic dish in that case. So all of those things you can obtain by just looking at what is my A. So where's my center? -2, +3. So put that down. What's my A? It's under the Y, so I'm going to go up 3, down 3. Under the X's square root is 7, so I'll go left 7 and right 7. Those up 3, down 3, left 7, right 7, up 3, O vertex, down 3, O vertex, left 7, O covertex, right 7, O covertex. And so those give you the vertices and covertices if you just count up and down. And if you know where that center is, you can say, what if I went up 3 more? And what if I went down 3 more? What if I went right 7? And what if I went left 7? And it's way easier than memorizing all of that gibberish in there. And then the equation for those asymptotes, you can memorize the formula if you want, and it's right there. But I know that I dropped 3, ran 7, so that's a -3/7 slope. And I know I rose 3 and ran 7, and I know the center because that's what I get before I even draw my box. And if it asked about the foci, they would live out here. Let's do that for this example. So in this case, C squared should be, and it is important that you get it right. The A squared is 9 plus the B squared is 49. And that means C squared is 58. And so C is root 58. But what that means is up here somewhere, and I'm going to erase this, up here somewhere is a point, and the coordinates of that point is -2 and then we went 3 to get to there, but then we went up root 58. So we're going to go up root 58, and then we have negative 2, 3 minus root 58. And I'm going to put both of those in on this graph to show you that they will sit in a very nice spot. So we have the point negative 2, comma 3 plus square root 58. And then we had the point negative 2 and 3 minus the square root of 58. And so those two values right there would be the foci of this hyperbola. And I can't make it any easier than that. And so, again, just to do it, the opposite of the x is the x coordinate of the center. The opposite with the y is the y value of the center. What's under the y dictates the up-down. What's under the x dictates the left-right. From the center, always. Draw your box, draw your asymptotes in after you have that, and then figure out who gets the negative. Whoever gets the negative, that's the way the bottleneck flows. And once you know the flow, then the top and the bottom, in this case, become vertices, and these two are co-vertices. But you know how to get to them. You were at 2 and a height of 3, and you went up 3, and you went down 3. You were at negative 2 and a height of 3. You stayed at a height of 3, but you went left 7, and you went right 7. So those are there. Do the Pythagorean theorem, and it doesn't even matter if you mix these up, because if this was 49 plus 9, we'd still get 58. And so even if you did it wrong, it's okay. And in the ellipse, it's always the big number minus the little number. And that's because if not, you're going to get a negative, and then you won't have any foci because they'll be imaginary due to that square root in there. So that is the process, and that is everything in here. And as a matter of fact, if you went back, these are easier because they're just centered at the origin. So I tried to show you one example here at the origin first. With this, and then we talked about how things worked, and then I came here and I shifted it, and so I've done kind of one of each. I did an up-down one at the origin, and then I did a left-right one centered somewhere else. It was over here though. So that is all the information that I can give you for now. If you look at the homework, now let's talk about it a little bit. So in these first problems, it says determine if it does represent a hyperbola. If so, write it in standard form. So in this case, in 6, the answer would be no. Why is it no? Because both the x and the y need to be squared, and the x isn't squared. Right there, you can say no. But also, one of them has to have a negative or a minus sign, and they don't. And so that is kind of disheartening. And so in 7, that is, and it is in standard form. And one of them's plus, one of them's minus. And since y gets the minus, you know the bottleneck's in the y direction, so on and so forth. This one, when you divide by 400 to make it 1, you will get a 16 over here and a 25 over here and a 1 over there. And so that one is also. These, it says write it in standard form if it's not already. Identify the vertices, the foci, and write the equations of the asymptotes. What I would do if I were you is write it in standard form and just do these for now. I'm going to tell you this. These take completing the square. And so I will show you those, and we'll go through those in tomorrow's video that I make. So these you could do right now. Some of them are shifted, and some of them are at the origin. Then down here, it says find the equations of the asymptotes. Again, I would just start graphing them and do it that way. And then here, It's actually to sketch a graph of them, and so that is exactly how I did it in those couple examples in there. And then tomorrow we'll also address those. So hopefully that will get you started, and that's a decent amount of information. And I wish you the best, and I'm proud of you. Hang in there, and we'll talk soon. All right? Bye-bye.